Hello everyone, warm greetings from Birla Divya Jyoti. We, the students of class 11 science stream of Birla Divya Jyoti, congratulate everyone on the National Science Day. Science is an integral part of our life, an aspect of our life that goes hand in hand with everyday's activity. We cannot deny the existence of science from life, and neither can we pull away from the existence of science from our life. So here we are, celebrating National Science Day with a presentation. Thank you and hope you all enjoy the presentation.
Today we are going to explain about Tesla globe, which we have created as a demonstration model. First of all, we need to know there are two types of electricity. First is static and another is current electricity. So the electricity which remains at the rest is known as static electricity, and which flows through the wires is known as current electricity. The lightning bolt is an example of static electricity, and the electricity which we use in our home appliances is current electricity. This experiment was first performed by Nikola Tesla. He was Serbian-American engineer and physicist. He invented the first alternating current motor and developed AC generation and transmission technology. So here is our model, which is based on Tesla coil, and it was one of his famous experiments. So what is Tesla coil? Tesla coil is an electrical resonant transformer circuit which produces a high voltage alternating supply. We are talking about in order of 2 to 5 kV, and the frequency is about 35 kHz. Tesla coil achieves its resonant frequency. Then it discharges a high voltage current, which we call plasma. And plasma is the fourth state of matter. So what is plasma? Plasma is an ionized gas, a gas into which sufficient energy is provided to free electrons from atoms or molecules and to allow both species, ions and electrons, to coexist. So what we created is a plasma globe. Here is a basic circuit of Tesla coil, and it looks something like this.
So we have our main supply. It goes to a step-up transformer. It is also called a high voltage transformer. Then it goes to a high voltage capacitor. We have a spark gap here. Right here we have a primary coil and a secondary coil. The most important part of a Tesla coil. Transformer charges the capacitor to that level until it discharges the current. When it discharges, the spark gap ignites and make a closed circuit. In the first step, the current goes something like this. And in the second step, when it discharges the current goes something like this, and creating a high resonance electromagnetic wave, which is used to power the Tesla coil. Here we are demonstrating our plasma globe. This is our primary coil, this is our secondary coil, and this is spark plug. We have put the circuit inside the box. This is our globe or bulb. One end of the secondary coil is connected with the bulb and another is acting as a ground wire. So let's off the light and test our Tesla globe. So now we are powering our circuit. So this is what our plasma is.
morning to everyone. Today is our National Science Day, the day that is celebrated in order to commemorate the discovery of the Raman effect, which was done by a renowned scientist and physicist, Sir C V Raman. And on this very day, I, Nandini Gupta of Class 11 Science, is here to talk to you about one of that scientists whose work made a huge impact in Indian science and technological field, but his name is still forgotten. His name is Dr. Shankar Abaji Bhise. Dr. Shankar Abaji Bhise was born in Bombay in April 67 to a Marathi family. Throughout his lifetime, he made 200 innovative inventions. His invention dazzled the Britishers too, and many investors and international investors believed that his inventions could revolutionize the global printing system. His inventions in printing industries like the typecast machine, Visotype, and day-to-day stuffs, kitchen appliances, were some of the examples. He even helped in the making of a seaweed remedy that was later used in the malaria treatment. Dr. Shankar Abaji Bhise was a pioneer scientist in the 19th century. He was self-trained and made many innovative inventions. But his work is even done today, but his name is still forgotten. So on this day, I would like you to take a moment and remember all those scientists and many other unsung scientists and his famous work. Thank you.
Today we are going to show that how a natural indicator works. First of all, we need to know about indicator. Indicator is a substance that helps us determine whether the given solution is acidic or basic by observing its color change. There are two types of indicators, natural indicators and synthetic indicators. Today we are going to talk about red cabbage, which is a natural indicator. Now the question arises, how red cabbage changes its color in different medium. And the answer is, red cabbage contains a water-soluble pigment called anthocyanin that changes color when it is mixed with an acid or a base. The pigment turns red in acidic environments with a pH less than 7, and the pigment turns bluish-green in alkaline environments with a pH greater than 7. So let's test it out. First of all, we need to cut a red cabbage into small pieces and then put it into a jar. Now pour some hot water in it. After 10 minutes, let's filter it. Now we have got our indicator. So here we have taken different kinds of substances in each glass. So now we are pouring the red cabbage indicator in each glass and observe the different types of colors that we get to see. First glass we have taken a cold drink, and in the second glass we have taken a bleach solution. The third glass contains water, and in the fourth one we have taken baking soda. The fifth one contains sanitizer. The sixth glass has sugar solution, and the seventh one has vinegar in it, and the last glass contains lemon juice solution. So this is how the red cabbage indicator shows different colors in different types of solutions.